Hello everybody, we continue talking about some things that influence on the result, difference in statements that affect or influence on result, and today we talk about meshing, but not about size of meshing, about type of meshing. That's the picture that we already seen. I change scale factor to maximum, automatic maximum, and as we see in previous video, it's a object with full fixation on those three faces, with 10,000 of newtons here, and with all contacts which converted from bonded to frictional. That's a very physical behavior, but we have some problem, and the problem is maximum stresses around 400 megapascals, and we can see varieties. So for this one we choose those two bolts, hide all other bolts, and select equivalent stresses, and we see that we have equivalent stresses on those objects. They look like this one. We have also place with hotspots on these places. We have some sharp corner, we have some problem with geometry, and if we say undeformed, we will see that we also have some problem on this geometry, and here also. But it's not very important that we have some problem on some geometry. Let's invert our visibility and let's take a look to this object, and we will see that current mesh of this hole in undeformed way also has not round view. So if you see, this is our cylindrical face. This is our cylindrical face, and this is also our cylindrical face. So we have some interference between two objects, and this interference came only from coarse mesh and from mesh method, mesh creating method. We have those problem in reasons that all mesh are triangle. We have only tetrahedral elements here, and it's very good that we have second order of elements, but there are some problem. Okay, let's do some changes. What do we can change? Let's hide all other bodies and select mesh for these two parts. And as you see, these mesh are much more adequate. It uses brick or wedge element, and it's very curved, it's very smooth here on this surface. We do it with the method of multizone. These objects are very simple. This object was meshed, and we can see this result even on mesh, not on result. Okay, change invert visibility. we see mesh in automatic mode with those problems here, here, and so on. And we see how mesh for this object looked here. So this is mesh much more adequate. Invert visibility. This object very difficult to mesh with only quadrilateral elements, only with brick elements. So we can use method multizone, but it will not work because geometry are very complex. We can try to do hex-dominant mesh, and in some reason with smaller mesh it will work. With current mesh settings, its default mesh size, we can't create hexahedral mesh, not for this part, not for this part. But if we take a look here, we see much more adequate mesh here, and reason of that, look at this form, and for this mesh, for this face, we create a face meshing control that creates better quality mesh even with tetrahedral elements, and how it influences on our result. We have maximum, show all bodies, we have maximum results, but not on bolts, but on edge of this base, and it's more physical. On these bolts, we can see places with some maximum stresses, but it's more adequate. And if we, and on this bolts is here and here, and if we say true scale, show all bodies and on section, we will see that this maximum are near this place, and this maximum are after this one. And if we change our scale to maximum, we will see why. This object, maybe it's very big scale, so let's do it in this way. As we see, this object try to hit bolt here on this place, it's in scale, it's very big scale, so this object try to hit here. That's why we have hotspot stress here. And also we have some hotspots here and some hotspots here in the same reason. It tried to imprint, it tried to go through our crank. So it's interference here. So that's the reason of big stress here. And on this model we have the same situation on these cases. Crank are not interference on this corner, but interference here and here. That's why we have bigger stress. So what we should understand from this effect. Our mesh had very big influence on result. Sometimes you can obtain much better result not by changing size of mesh, but with creating more adequate mesh distribution. And this mesh distribution will give sometimes more, sometimes less elements and nodes than original. Sorry. As you see, it's almost the same, but result much more adequate. So that's why you need know how to create better mesh for your object. Not only change mesh size and go on. No, it doesn't work in the same way. You must know not only physical process, but numerical methods and some approaches of meshing too. Hope it will be helpful for you. Write a comment if that's so. Bye.